Now, for the surface analysis tools, these let us think about at a molecular level, the way our different surfaces behave in terms of their surface chemistry, in terms of the roughness of the surfaces, and in terms of the charge on the surface as well. And they allow us to produce some really quite nice, pretty pictures as well. So what we're doing is we're generating a slab that represents the surface and the terminating surface of our particle, and we're really generating a van der Waals surface over the top of that. Now we can use that van der Waals surface to describe and visualize a lot of different properties. So you can see this based upon different chemical functionalities on the left-hand side here, where our blue areas represent where we have hydrogen bond donors. Our red areas represent where we have hydrogen bond acceptors, and our orange areas represent where we've got aromatic bonds across our surface. And we can also derive different descriptors from those surfaces by thinking about the densities of these functional groups, as well as some physical descriptors like the roughness of our surface or the skewness or kurtosis of our surface. And there's more information on what these terms mean in the glossary of your handout today, and we'll cover that in a little bit more detail in the hands-on part. But we can also apply statistically derived interaction data, or these full interaction map approaches. So by thinking about our solid form and generating our surfaces of interest, we can use that information from the CSD to think about where we might have interactions occurring on our surface. So here for this surface, you can see where we can identify areas where we're likely to see water molecules interacting with our surface. Now that can obviously be very useful for thinking about how surfaces get wet. And so it's a nice simple combination of these different things. If we think about our full interaction map, so again, this is our molecule here. The blue areas are where we expect to see hydrogen bond donors, and the red areas are where we expect to see hydrogen bond acceptors. This translates perfectly well to thinking about our surfaces here. So we know that we have these hydrogen bond acceptors and hydrogen bond donors on our surfaces. When we combine those two, what you can see is that we have areas of hydrogen bond where we expect to see hydrogen bond donors line up with our hydrogen bond acceptors, and where we expect to see our hydrogen bond acceptors line up with where we expect to see our hydrogen bond donors. Now, we'll go into that in a little bit more detail later on. You'll be able to explore that yourself. But what you all really came here to see is the CSD-Particle menu, and you can find that in Mercury as well. So you can see there's 3 key bits in it about morphology, slip planes, and surface analysis. Clicking on the surface analysis select option in the CSD-Particle menu brings up this bigger menu for the surface analysis dialog box, which is split into different parts. The Analyze section at the start lets you specify the surface that you're interested in generating. So that's based on an HKL indices and an offset from the mean plane defined by that HKL. Once you're happy with the plane you've selected, click Calculate Surface, and that will generate this surface over your molecule. What you'll then see is your results are updated. So this will tell you the ref code or the structure that you're using, if it's your own structure, the HKL values, and the offset that you selected for the calculation. This will give you information about the density of different functionalities across your surface. So you can see the density of hydrogen bond acceptors and donors, and it will give you some topology information as well. So measurements like the total surface area and the rugosity. You can also change the display options. So by default, it's set to just a plain color, and it comes up with it in off-white, but you can color it based upon atom properties, so highlight where you have hydrogen bond acceptors, hydrogen bond donors on the surfaces, or you can color it based upon topology as well. There are some advanced menus that you can make, advanced options that you can make use of. By default, the surfaces are generated in a 1x1 square, but you can make that a little bit larger if you want to. If you want to make a larger surface for publication or to visualize something a little bit more clearly. Be warned though that making a bigger surface is a little bit more demanding on your graphics card and on your computer, and so it might take a little bit longer to run if you do. Now, the way that the surface is generated is based upon rolling a probe of a given radius across a given grid spacing across the slab that represents the surface. Now, the default values have been thoroughly tested to make sure that they're right for small molecule crystals. You can change these if you want to, and you can change the thickness of the slabs that you generate, but I recommend that you really know what you're doing before changing any of these structures, before changing any of these parameters. The default values have been thoroughly tested and are really the most appropriate ones. And those full interaction maps on surfaces can be accessed by clicking on this button once you've generated your surface already. What that'll do is it'll open up this dialog box for full interaction maps on surfaces. This looks almost exactly the same as the dialog that you'll be familiar with from having used the fins option from the CSD materials menu, but it just lets you do those nice calculations, those maps across the surfaces themselves.